Today on Race Tech, we're going to cover brake cooling. We discussed it in the intro to brakes, but the primary role of your brake system is to convert kinetic energy from the car into thermal energy in the form of heat. You need to get rid of this heat to prevent excessive brake pad wear, rotor cracks, or failure in other components of your suspension and braking system. The brake heat is going to escape from your brake system via cooling fins in the rotors. Some of it will be transferred from the surface of the rotor. Some of it will escape as heat drawn off of the caliper. Some of it will go into your hub and potentially wheel bearing system through heat transfer through the face of the rotor. All those are cooling paths that will absorb that brake heat, and you need to consider how much of it is transferred to each of those components if you start experiencing these failures, like wheel bearing grease failure, where it gets burned out and then you have bearing failure, or if you have failure in the other components like seals in your caliper. Dust covers. Most of our cars came with dust covers from the factory. These have a couple functions on street cars. One of them is to keep brake dust from getting to the wheel and making a mess. Sometimes they're used as splash shields to keep water out. In general, it's easier just to remove them and either go with nothing, or if you want to have a forced duct where you blow air on the rotor, make one from scratch or use this with the hose to make an actual duct. Wheel blockage. Something else we don't really think about when we're picking wheels is the effect the wheel will have on our brake cooling. Most of the wheels you're going to find at aftermarket offerings are going to be fairly open with a lot of area between the spokes, and this is good to help evacuate air that's been pushed out from the rotor. If you run steel wheels, you need to be careful of the actual opening size in the spokes and make sure that it's not restrictive enough to limit the airflow from your brakes getting outside of the wheel. If you're having problems with your brake cooling, another option could be to go to forced cooling. We talked about passive cooling earlier, which is just the natural airflow over top of your brake components like your caliper and the outside face of your rotor, and the actual pumping effect that your rotor has where it will draw air in and push it out the vanes. Forced cooling can be provided either via fans, like this one here, or it can just be ducted and work via the higher static pressure that exists on some part of the car, like near the hood or in the front of your car, versus the pressure that exists out at the wheel. If you need forced cooling and you're trying to decide between fans and ducts, a couple things to keep in mind. A fan setup will require electrical power from your alternator. Depending upon how big your fan is, or fans, you may actually be drawing a significant amount of the total output of your alternator. If you operate at a lower engine speed, like mid-corner or during a caution, this could actually result in you drawing down from your electrical system and your battery to the point that the car actually no longer has enough charge to run. Another consideration would be the crossover of speed at which a ducted system or a fan is more efficient. Fans are better at slow speed. After a certain velocity, the actual fan blades present a restriction, and a straight through duct may actually be better. This crossover speed can vary from between 60 and say maybe like 100 or 120 miles an hour, depending on how good your fans are. Just because your car can reach 100 to 120 miles an hour at the end of a straightaway doesn't mean, though, that the crossover speed you want to pick is that fast. Most average speeds around a Champ Car track are about 60 to 80 miles an hour. And at that velocity, a really good fan setup is probably going to outflow a duct. Another issue you may run into when running fan setups is foreign matter being drawn into the fan. You need to put a shroud or put a net on the outside to make sure that you don't suck in rocks or tire particles and get them stuck and wedged between the edge of the fan blades and the housing. If you do this and the fan stops, it will draw a lot more current than it would when it's free spinning, and if you don't have a circuit breaker or some other protection, you could actually burn up the wire leading to the fan or burn up the fan itself. When sizing a fan, you need to pick out a fan that's going to have sufficient flow rate, and if you don't have good data on the fan, a rough indicator will be the electrical consumption of the fan. So if your fan is something that draws 5 to 10 amps, that's going to be fairly good. If it's a bilge fan for a boat that draws 2 or 3, that may not work. So look for something in that 5 to 10 amp range if possible. If you can't find something in that range that works for you from a financial standpoint or a fitment, you may just want to revert to a ducted system. If you're going with a ducted system, the placement and location of the inlet for your ducts can make a huge difference in the amount of flow delivered to the caliper or rotor. You need to pick something on the front of the car that's going to have a high pressure area, like the air dam or near the radiator, but you don't want to place these low enough that you're constantly drawing particles in to the brake system and leaving rocks or tire debris in the rotor or on the calipers. Look for a spot that's slightly below bumper height, but at least a few inches off the ground if possible. And make sure you put screens or some other protective matter on the outside of your brake duct inlets to keep large particles from getting ingested into the brake system. Also think about crash damage and placement of the brake duct behind some major structure like the bumper to ensure you don't knock it off the first time you run off track or have a minor contact with another vehicle. Forced rotor versus forced caliper cooling. You can run forced air to either your rotors or your calipers or both. Running more forced air to your rotors should decrease the rotor peak temps and hopefully reduce cracking or warping of your rotors. It will also draw down the peak temperatures for the rest of your brake system because the rotor is the primary location where the heat is rejected. You can also reduce hub temperature and wheel bearing temperature issues if you're having problems with cooking the grease out of your wheel bearings. Running forced cooling to your caliper will decrease your pad peak temperatures if you're having problems with your pad wear being a little bit excessive. It can also prevent or reduce boiling of the brake fluid. And if you're having a problem with brake caliper seals, running cooling to your brake caliper can help fix those issues as well. It's important to look at your caliper, your rotor, and your pads to figure out if you need more flow on your rotors or your calipers or both. Does brake cooling matter? Well, that depends on the weight of your car, the size of your braking system, and if you're currently having problems or not. If you're not running into any issues, you're making it 2 races on rotors, 1 or 2 races on brake pads, 2 or 3 races on bearings and hubs, then it's probably not an issue. If you're not to that point yet, adding brake cooling might be a cost-effective way to increase the lifespan of those parts and reduce your operational costs. That's it for brake cooling. Make sure you click and subscribe. Add any comments or questions you have on this topic or any other topic. We'll see you again here on Race Tech.